Hey everyone, today I'm going to do a video on simplifying curves. So I wanted to go over this because I've had a project like this that I'm working on professionally at Corestone, the company I'm working at, and I thought it would be an interesting thing to go over with you guys because there was a lot of thought process that I was thinking at the time that I think can be applicable to a lot of scenarios that you may encounter while computationally designing or scripting or using someone else's work to script, etc. So I just wanted to go over my thought process on how I did this, and yeah, so let's get into it. So this isn't the exact text. So the premise of the project is we have a bunch of pavers with a bunch of letters on there, and there's a bunch of text. It's like thousands of rows or around thousand something rows of just solid text, like tons of it. And but the problem is this person or the designer created an Illustrator and then exported it incorrectly and then created text that was very dense. So I just made this text as an example to show you guys that I thought would be a very interesting way to show you guys how I did this and my thought process. And maybe if you guys have a better process, it would be interesting to see that as well. Excuse me, my throat's kind of sore, but give me a second. Always keep the water on deck. So anyway, so what I did was I just found some text online, just some dummy text or lorem ipsum text, and then grabbed it and then did explode to get curves, and then yeah. So what I wanted to do is, so if you see these curves, they're pretty good. The point division is very reasonable, just enough to get that curvature, and etc. And then the flat, as you can see, it's basically like a polyline, and etc. Yeah, so it's very good. But the problem is when you're using someone else's work, they don't always know what they're doing, which is perfectly fine until you have to deal with it. And then so what I was given was this. So the text looks exactly the same, but if I click on it and I do points on, it's grouped already. You get this super dense text. It's like insanely dense. Like if I isolate this or ungroup and then isolate and then explode, you get like all these are different segments. And that's what happens when you don't export from Illustrator properly. So that's what you get. So I wanted to go over how I resolved this problem from turning this text to something like this. I wouldn't say exactly the same, but something like this. So they're control points and they're a lot less dense. So let's go over that. So my thought process here was I would make a bounding box for each one of these letters and then just replace them just through a system. So I would have like just A through Z already cataloged, and then just move them move to point on each one of these letters. But that proved to be pretty inefficient. So it didn't work. Let's just say that. And there was a lot of problems with it. The letters were the same. Some of them were the very, very similar size in regards to the bounding box and etc. The text that I was working with was all capitalized, so like caps lock. But in this case, they are lowercase. So there's a lot more curvature that can go wrong. As you can see, a lot more dense curves can happen, which is good for this case. So I can show you guys more examples on how I do this or how I did this per se. So what I was thinking is before I even scripted, I identified each letter that was wrong, or not wrong, but each letter that was kind of like problematic. So for example, there'll be a lot more in lowercase letters, but for the capital letters, I'll go over, it was mostly B, O, Q, and D, because even though these are flat, these curves added a lot of problems, along with C as well. So yeah. But what I figured out was that these curves, just like these ones here, or just like the ones I was working with, have these flat parts. So it's literally a polyline. As you can see, it's a very dense polyline. So line, 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 and a bunch of lines here, etc. I apologize. My throat's all screwy right now. I have no idea why. But actually, where were we? So the R in this case were, let's use the C for example. I noticed that these are super dense, and then we have these lines, just like the R that I had. And then, so I could basically filter based on length. So I was like, okay, I could do that, because if I filter it based off these lengths, all these segments are super tiny. That's what we're trying to get rid of at the time. This is what I'm trying to get rid of. So if I can capture these larger segments and keep those, I don't have to rework with those. I just have to use those, modify only these kind of arc pieces that we have here, 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 and then it'll be good. And then I just remake these arc pieces with Interplay Curve and then join them. And then it should be good, right? So that's exactly what I tried to do. So I opened up Grasshopper, if I can find it. Oh, that is. So let's open it up and try it. So what I did was, what you can do is you can highlight all of them and select them all. But you don't want to start with that because these are so dense. Now, I only highlighted a couple of them, so it seems pretty good. But imagine if you had thousands of these things. You don't want to test. You don't want to test to see if this works on thousands of things. You want to use a fragment. That's why people make fragments or test codes in order to make sure it works before you apply it to the entire thing. So I'll clear value here, and I'll go to one word. We'll just go to this one. So we picked a lorem. Okay. So if I isolate that, or if I isolate, and let me move this mic. Sorry if I play with this mic too much. I just want to make it pretty, I don't know. I just want to make sure you guys can hear me, because I know with all my other videos sometimes it's pretty hard to hear me, but I also need to be able to type. So apologies for that. So let me think. So what I did was I had this text here and these curves. I'm like, okay, what do I need to do now? So what I need to do first is explode this entire thing and get these individual curves. So this curve, this curve, and then etc. Okay, so now what? I know that these are all certain lengths. So what I can do is, what I'm thinking is, I know all these segments are super tiny. That's what I need to fix. But I don't need to fix these longer pieces that are very well defined. So what I did was, I did a length into segments, and then I did a less than, well, that's larger, it's smaller than, and then I went to first number, which is the lengths, and then the second number. So what is your second number? What number are you basing this off of? So what I would do is do distance, and then I would go to, let's just use this E for example. So 0.73. So we'll type in 0.73. Just try that out. And then we're left with what smaller than does is it leaves us with a bunch of true false statements. So saying it goes into the list and basically says, are these values true or false? So are these values, is it basically saying, are these values smaller than 0.73? So as you can see, true, 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 and then there should be a false here and there, right? It's these segments, there's only a couple of them. So what you're gonna do now, to read that data, you do a call pattern. You wanna read these segments with this list. And as you can see, if I turn this off, you get all the larger segments you don't want to modify. But it's also capturing this segment, which is what we don't want. So what we're going to do is just raise the number. Or lower, sorry, my bad. Lower the number. So anything smaller than 0.71, it will capture. And then if you want to make it a little bit, if you want to make it a little bit easier, I don't know why Bunny's at work is playing. I don't even know who that is. But so if you want to make this smaller, or if you, not smaller, if you want to make the other end, so if you want to capture these curves, all you have to do is just basically reverse this true-false statement. So how would you do that? Well, there's a command called gate not, and that basically just inverses the true-false statement. So as you can see, most of these are now false, and then a couple are true. So if we do a call pattern here, we plug our list into the same area, segments, and then our call pattern into gate not. We get all the curves. So these are all the curves that we don't want to modify, and these are all the curves we want to modify. Pretty simple stuff. So now that we have those captured, we can now do what I'm thinking is, all right, so now I have the segments. I need to re-explode this. It's going to be a running theme through this script. So I exploded it to get these vertices. And now all I need to do is interpolate curve. Right? Should work like this. And it does, see? Sometimes, though, you will not get this to completely work. It will do stuff like this. So it seems to be working, right? But in reality, it's not. So I need to lower it down a bit. There we go. So as you can see, I lowered it a bit because we only need these R arcs to be fixed, not the other things. So it's just a tweak you have to do depending on what lettering you're doing. Now I'm looking at this, I'm like, okay, this clearly isn't working. So you have to be like, okay, what am I doing wrong here? This is, I mean, I ran into this exact same problem. First of all, it's saying insufficient points, but you see it's working here, right, on the screen. So you're thinking, what's going on? It's red. There's a problem here. Insufficient points. Well, basically, it's just making a line. It's just remaking the polyline. It's just remaking the polyline, which is not what you want. See, if you highlight this, it's just doing the exact same thing, and that's not what you're trying to do. You're trying to simplify it to make it into control points or something less dense at the very least. So let's think about this. So I'm like, okay, I don't want this. This isn't working. So what am I doing wrong? Okay, so I'm going to delete this. Now, let me think what I'm exploding. If I go put in a panel, I'm basically just exploding a bunch of curves. A bunch of tiny, tiny curves into basically just almost endpoints. It's basically doing endpoints into here. So, as you can see, I get the same thing here. And if I do interpolate, if I merge these and then do interpolate, you'll get the same result where it doesn't work. So if I do this, interpolate, where is it? And boom, same thing, insufficient points, and you should get the same result as this. Oh, maybe not, wait. Interesting, I thought it'd be the same, but, or maybe I'll have to graph these, but essentially, if you merge them together like this, you'd get the same result. That actually could work, but anyways, you get the data looking like this, and the problem with this data too is it's not fully organized. So it's just the start points of those curves and then the end points. So it's moving in a really weird way, something that we can't control very well. As you can see, there's just an empty list randomly here too. So it's just a messy list. So let's not do that. So now, what am I thinking of doing? So I want these to be one curve, right? And how do you make all these lines into one curve? You would join them, right? So let's join them together. I'll plug them in here. And then what does this say? What's going on? Insufficient curves for joining. So we have to think, okay, what's going on? So we have all these curves. So my first thought is usually when you join curves, you usually need to flatten them. Okay, so flattening seems to work. And now we're stuck with these polyline curves. So it's simplified. No, it's just joined, not simplified. It's just joined together. That's it. So all these curves are now join together. Now, where are we going with this? So, all right, so now I have my explode here. Now, so what I did was, let me re-explode this joined curve. Okay. So you're like, okay. So if I do interpolate here, we get this. I mean, do you see a difference before? So don't worry about how it's listed, like it's grafted, but that's not the point. The point is how it's listed here. So these now explode, and the vertices are now grouped by these M's. And there's a problem right here, but we're gonna go over that, and we're gonna go over that later. But anyways, so even in fact, I don't even think we need to have that. You just, there we go. Cool, even better, sweet. See, it's just little tweaks. Sometimes you gotta check letterings and things like that. So when you apply it to more letters, you can check to see if it works. Technically, you can also just copy A through Z with this exact same font and text, and then try it with all of them and see if it works. That's another way to do it. But I didn't have a lot of time, so I just used chunks of the text that was given to me in order to figure this out. So what I did was I interpolated this, and now you see that the curves, now it's one planar curve. Some are closed because of E, so the two closed ones I'm assuming are the O's. Yeah, not E's, the O's, my bad. So that's good. We now have these curves here, which is good. And then we can test this out by doing control points to check out to make sure it looks good. So I'm going to go turn this curve on and then control weight. And you would see here that these points are still pretty dense. So you're like, okay, this clearly still isn't working. So what am I doing wrong here exactly? Because you still have all these control points. All right, sorry for the pause there. I had to get something real quick. Not just the cough drop, but some other stuff too. So my bad. So we were left off with control points. So when we turn this on, we're like, okay, this is good. We now have them all planar. So if we bake this, we can see that, well, if we make it here, we can also see it here, but let's bake it to, I guess, show what I'm talking about. Go to group and then move these up. So these are all the curves that I modified. And if you go to point on, you can still see it's very dense. It's not very it's not very simplified. You can see, yeah, it's control points, but they're still dense. This is better than the polylines, but still not good. So better, but not good enough, basically. So let's keep going. So we're like, okay, why is it doing this? Well, why? What do I need to do, basically? I just need to remove vertices. So the way I'm thinking about it is, I know that there is a way to reduce polyline vertices. So if you do reduce here, you can actually control the amount of polylines or amount of points in a polyline. So it kind of simplifies it. Now, this is really, really useful. You could also do rebuild curve, but rebuild curve. I think this one's pufferfish. You can use this one too, but there's also the native one as well. I don't know where it's at here. Yeah, so under utility, rebuild curve. You could do this as well. It's not as, I won't say as good. I don't know. It's not the best. I find that reducing the polyline and then being able to visualize how the division's happening really shows like how the curves will average out. That's just the way I did it. But you can feel free to use rebuild curve as well here. So maybe I'll show that after I finish with how I originally did it with Polyline. So what I did was I took the vertices and I drew them out. As you can see here, it's still better, but it's basically taking interpolated the average of these two rather than going point to point. So what I did was I took that polyline and then reduced it. So right now the tolerance is 1. So if we look at this, we zoom out, we're like, holy crap, what's going on? So the tolerance is the deviation between the original and the reduction. Okay, so once I make this number 0.15, let's say. Okay, so it looks faceted, but a lot better than 1. So we can now kind of play with it and get a decent result. Okay, right? Maybe go to 0.6. And we're like, okay, cool. Let's try that out. So what we need to do now is take that polyline, explode that again, and then go to vertices into here. And we can see it's creating that arc. So this is the original curve, and this is the curve that we created. So you can see it's averaged out. It's very close, but not perfect. It's never going to get exactly perfect, but you want to get as close as you can, right? That's the point of this. So what I'm thinking is, all right, or what I was thinking, or even what I'm thinking now is, all right, so what we need is more tolerance or higher tolerance. So just scroll down until we get to the right one. That looks pretty good. So this deviation looks pretty bad, actually. I don't know why it's so terrible. So I usually just hide these. So this is the original curve, or this is the curve I created, and this is the original. So what I usually do now is I take a panel. I don't like to use number slider for this process. I don't know why. It just doesn't seem natural. I can try number slider for you guys. Maybe it'll be easier for you guys to visualize. So rational number, 3 decimal digits. I'll do from 0.5. And then, so we can see. So see, the lower we get, the higher deviation we get, or the lower deviation we get, the lower we get, and then the higher, obviously, higher we get. See, so we want to get somewhat close. The deviation can still be okay, but not terrible. Like this is like perfect, and then so 0 is perfect, and then we get this number. So that's like the sweet spot I think we're getting right now. We could raise the number a bit, I would say. Yeah, that's fine. You don't want to usually look at these control points. You want to look at the curve itself. So what I do is I highlight the curve, and then I just zoom in. See, it's very close, which is fine. So because we're just trying to reduce it, it's not going to be perfect. We need to reduce this. So once we have this, we can now look at this and be like, okay, this seems pretty good. All right, let's try this out. So I'm going to delete this. All right, now we can go back in our script and find these vertical lines we have, all the lines that we didn't need to modify, and just join them with this, right? It'll make the same thing. So we just do join curves and then a merge. So we're going to merge these together first. Oops. Modified, and then the non-modified, doesn't matter the order. I just ordered it this way. Flatten this because you want the data to be red as 1 here, and then join curves. Because when you join them, they need to be flattened. They don't need to be flattened, it just makes it, so for example, if it wasn't flattened, you'll join these curves together. It'll just read in that list, so you're joining nothing. As you can see, insufficient curves for joint operation, which is this. So flatten, and then you get the curves that you need. So lorem. So if you go to control points here, and then turn these on, it's a lot better than what it was before. That is a lot better. See, if I zoom out, it looks dense, but zooming in, it's so much better. All right, and then usually I would set up a bake toggle here, but it's fine. Here I can just bake it here, and then now we have our lorem text. So this is the original, and this is the modified. Oh, I'm gonna group it. I usually group it so I can move it around. So original, modified. You can clearly see the difference here, which is really good. And then versus the O's is the easiest difference to see. Like, that's so much better than this. All right, so now we know it works with lorem. Does it work with the other text? There's one way to find out. So what I'm gonna do is I'm gonna keep this as a test piece, or just be like, okay, it does work for this. But remember, I only tested out 1, 2, 3, 4, 5 letters. There's other letters like A, C, quantum fells, or whatever. This is Latin. So, so you'd think, oh, highlight the whole thing. Let's just try that whole thing out. Well, not exactly. So I'm going to highlight maybe just a chunk of this. So just this chunk here and see if this works. So you start to slowly build it up until you get to the whole thing, so you don't, crash your computer. You want to make sure also your computer can handle it, because if the text is super dense, like you see it's already crashing, then I don't think your computer will always be able to handle it. So it's good to test it out to see if it will. And it's taking quite a while. I mean, I know why, but speaking of that, I also want to save constantly. So I'm going to save this here as let curve same thing for this file. I'll go to desktop, simplifying curve, just copy the same name, get rid of the extension number. Oh, we're good. So we referenced it. Let's check it out. Let's see if it worked. So we go here. So first thing I would do is, usually what I would do is you see the join took forever. The reason why the join takes forever is because the text itself is like a ton of polygons when you explode it. I don't know what it is, but that many. And can you imagine I had like 1,000 rows of this to do, so it was like around, I only did like portions of it, and it was already 2 million. So that should give you some perspective on making sure you export correctly, or else you have to do something like this. So, okay, let's check it out. So the L, the I seems to be good. D, okay, there's this problem here. I don't know we'll be able to see a problem with what I ran into, but I will show you guys if I don't run into it here completely. So what I'm thinking is, all right, so it's capturing everything pretty good. This is pretty good. The A seems kind of strange, so we need to fix that. And then A looking kind of weird too. I don't know what's going on here. Why does A have so many points? Especially capital A. That's so weird. Interesting. So we'll have to fix that too. Is there any other capital A's here? No, I can see. Okay. Okay. Well, this is the text I was given, and then this comma needs to be a little better as well. So, first thing we're going to do is just lower this tolerance so we can get these kind of smaller pieces. For example, probably this. There was one I saw. I think it was under N. Or D, sorry, my bad. So this curve, I don't know exactly what the distance is, but it should be pretty small. 0.52. Oh, so I just have to go like that. Well, it's gonna lag, but it should be like 0.51. Okay, well, and I'll just get back to you guys when it's working, or when it's, what is it, at 0. Whatever, 0.45. Okay, cool. Okay, so it started working here. 0.45. So it's a lot of just checking to make sure it worked more than anything for these areas. So here we'll be able to display what I'm talking about, at least with B, and then A especially. A has a lot of those. So if you see, not all curves are just like O's, or even like D, for example. They may have in the middle of it a kink, right here, and then here. So what we need to do is figure that part out. That part is really important. So what I'm thinking is, all right, what we need to do is take those and figure out how to keep that kink in those curves. So we can go back into the script and we can clear these values because we know what we need to work on. And I'm going to highlight A. A seems to be the one that doesn't work the most, right? All right, so we go to A and we're like, okay, we need to figure out why it's doing this. I mean, it's pretty simple. We just have these points we provided and it's following the curve. Simple. It works well with these, but doesn't work well with this or this. So we need to figure out how to fix that. So there's a command in here called Kinky Curve. I know, what a weird name, but I didn't make the name up. But it works. That's all that matters. So we're going to use this command here, or this kind of node that's been provided, and we're going to plug this into here instead. And already it's a lot better, actually. You can see it's already getting these sharp parts pretty well. So what we're going to do is we can turn this off. We can also turn off this and just see how this looks. So we're looking at this and I'm like, it works pretty well here. But what does this really do? So it says construct, if we read it, it just says construct an interplay curve through a series of points with a kink angle threshold. What does that mean? So basically, if we provide it with an angle, for example, even in the logo it shows, if we have a curve that looks something like this, like let's say in this description, if we give it an angle threshold, so this is theta angle, if we give it an angle threshold, we can easily we can tell it, okay, don't kink unless this angle is like this within a certain threshold. So anything below, let's say this is 45, just as an example. I know it's not 45 degrees, theta equals 45. If this is past 45 degrees, just do an interpolated. If not, just keep it polyline like this. So if the angle, if we're saying anything, this is 135, anything over 135, just make a curve. So now that we know that, we can go into here and change this angle. And right now they give it in radians, so you want to do is degree. Oh, oops, radian, my bad, to do radians. And then find a degree that you want. So what I would do is I would do angle in Rhino, and then get the first curve and then the second curve. Angle's around 109. So we'll say 110 to play it safe. Plug this in here, plug that in here. And we see when we go over, as you can see, it actually creates a curve there. That's the same thing with all these, right? It's creating a nice curve. Well, except for here. So what you want to do is take this and just lower it. So if we lower it past 108, it retains that kink, but also interpolates the curves. So the more you lower it, as you can see, when we get to 0, it doesn't do any interpolation, excuse me. So it doesn't do any of that. So when you raise the number up, it starts to do it because it meets that threshold. So it starts to meet that threshold here. So if you start to move it, as you can see, 93, it starts to do it. So lower it back down. Now you get this. So I'm like, okay, this is pretty good, but it doesn't look as good as even the interplay one that I have here. So what you have to do here, well, you don't have to do anything, but what I did here was I took this curve and I just raised the tolerance, or lower the tolerance by increments. So out to 4, see what that looks like. Okay, didn't really change too much. So let's keep going. Okay, 0.07. So ignore this and just pay attention to this. So this deviation's not too bad. This deviation needs to be lower. Yep, good. That looks pretty good. So we can keep this like this here. So if we plug this in instead, we get this. We can also lower it a bit more and do, let's say, 6. And then it should help with a lot of these problems we are getting. So 0.03. See, it's still more dense, but it's still a lot better. Let's do control points for the whole thing, which we did. So you see it still has control points here. Cool. So now we have A. Looks pretty good. Sweet. So A looks decent. So let's do not too much. Let's just do this. Let's also include a comma in here somewhere. Now in mine, I didn't have any commas. It was all letters, but in this scenario, let's make it as difficult as we can so I can show you the most scenarios. Okay, that looks pretty good. That's the original. And this is the product. We don't need this on. Cool, that looks really good. Sweet. I don't know. Yeah, didn't keep that, but that's okay. I don't know what that distance is. So you want to be able to simplify as much as you can. So this is 0.4. So just do 0.39 and you should be able to capture those. Alrighty, it should work. Yes, awesome, sweet. Oh, I didn't get the M's, or I just did the reference for the comma so I can show you guys. So P-E-M. So right now I'm just reviewing. I'm like, okay. Nice. Sweet. That's good. That's good. And then you can also review with the other one to see it's getting all the curves. Okay. Okay. Yeah. So it skipped L, obviously. Sweet. So now we look at the joined ones and then compare it to the ones we have here. Cool. This looks really good. So a way we can also do this too, like I showed before, this isn't the way I did it, but what we can do is we can take these. Oh, oops. So we just take these. We just do an interplay curve, plug the curve into here. Data version from number to curve. Oh, oops, I plugged in the wrong place. So curve. We have this being rebuilt. So this is the count 10. So let's do 15. And then we just play around with these values. Don't worry about this, because remember we can fix this with a kinky curve. Ooh, nice. So let's try this. So if we plug this into here, or should a curve? It's asking for vertices either way. So we can still try to explode this. Maybe this method doesn't work because it just gives us a curve here, which is not what we want. We want these points, and it creates it as a control point as well. As you can see, this one has more components or more variables you can put in, like domain. But okay, maybe this method doesn't work. I just figured that out now. I haven't tried this method. I only did the Polyline method. So maybe, well, that could be, if we undo, look at reduce, That should be rebuild, which we have. Or maybe fit curve, could curve to polyline. We could do this too. That's another way. So what does this give us? I've never tried some of these, so I'm literally experimenting with you guys right now. And that's insane. Okay. Nope. That's a lot. So. And it turns it into a curve, which is good, but maybe we can change the tolerance to be pretty high. Yeah, so tolerance is pretty high here. So you can see it starts adding points here. So this doesn't seem to work very well, but you guys can feel free to try that out. The only reason I'm not trying it out completely here, I don't want to like waste too much time here. I just want to show you guys what my thought process the entire time was. There's definitely other ways to do it. I'm like 99% sure. So if you figure out a better way, please let me know, of course. But this is the way that I came up with at the time. So yeah, so we have these curves here. So I'm just gonna move on. Sorry, my bad. So we have these points here, these curves. Looks pretty good. So now I know that this works. We can just try with the whole thing. So what I'm gonna do is, I'm gonna bake this and then select the group and then ungroup it and then select one of these and make sure it's still pretty good. C is more dense than this lorem. Oh, oops. Oh, this is the comma. So that still looks pretty good. Okay. So if we go to C and compare them, this is still more dense than this C. One, like I said, it's better to have control points, especially for Rhino. So we have control points. If we do this, cell points, it's 151 versus, which is 227. So it's pretty good still. So we could go in and be like, okay, let's look into this and then change this to be maybe 0.001. What was it? You can change this to be maybe 4. Ooh. Let me just type it. So we can look at it and see the deviation's not too bad. What you can also do with this reduce polyline, you can go and put in a panel here and then see the numbers, how much it reduces by per curve that we put in. So another way to do this, then we can go to average and then just see how much it's averaged by. So you have to flatten this to get the average of those points. So the average is 52 or 53 points per segment, or 53 vertices are removed per segment or per line. So obviously the more you raise this, the more curves you're going, or more vertices you're going to remove. So it's just you have to play around and fiddle with it and see what it does. Seems pretty good. Let's look at A. That's what we had a problem with. So I turned down the tolerance to make sure. So I do 0.05. Deviation's pretty good. So let's try 6. Looks pretty good here. Yeah, it looks really good. So we'll keep this. We'll bake this as a group. And then we'll, oopsie, sweet. So we'll keep this, delete these, and then keep this. So as you can see, this, if I ungroup this C, let's compare that C again. So I do cell points, 227, 103, way better. Let me move this back. Let me save, always save. So now that we have this is good. So let's try with the whole thing now, since we know a lot of other stuff. So we know most of it works. So the only way to really figure out now is to do the whole thing. Now, if you have a lot of text like me, you probably want to do it in chunks and then bake it, and then you'll be good. But what I'm going to do, since it's so little, I'm just going to do, just reference it, and then we'll be good. So I'll reference it, and then I'll just wait until it finishes. So what I was doing was I was working, I just referenced it, and then let it load, and then I moved on to a different project I was working on as well, while that was working in the background, or on another computer, because I have two. So either one works. So it will take a while. As you can see, these are a lot. This is a lot of time, especially for this. Jesus. So select multiple curves, and then pray. So I'll be back with you guys when that completely loads up. All right, so it looks like it's already referenced. I'm back, and as you can see, it took quite a while. And now that we have it back, let's see. Oh, you can see it's a bit laggy because, you know, obviously text. So we can see the S looks a little funny. Okay. The S's look kind of weird. Don't know why it's doing that, but I can check that out through this. So we can look at which curves are used. Then we can go to how those curves are made, which is this one. One thing it could be is this angle. So we can change this to a different angle. So we'll do like 40. See if that improves it. We can also change the tolerance as well. So that gives us this result, which looks even weirder. Let's see what that does. So this seems to be the better option here. Okay, so I could tweak around with this a bit more, but we have the letters here. Oh my God, let's turn this off. So S seems to be the weirdest one now. We have to fix this kink here. Don't really know why it's doing this. I'm gonna have to figure that out. This is the Interplay version, which works pretty well for S. So it just could be this angle that we have. So what we need to make sure is, yep, so the A doesn't happen, so let's change this back to 50. All right, I don't remember what number I had. I think it was 6. I don't know. How big's this number? I think it was... I have no idea what number I had beforehand here. Okay, that's a little weird. What number did I have here before? Radians, okay. Let's see, let's just try an extreme number. Okay, so it's probably lower. Oh, I have this on. Okay, I was like, what's going on? Why is this not working? Am I stupid? So, all right, so this looks a little better. This deviation isn't terrible. We can live with that. And then 10 here, let's not do that. Let's do 20. Okay, 20 seems almost perfect for these. I can do 30. Okay. That looks pretty good. I think we can change that S. I don't know why the S is doing that though. It's so weird. So if we go to 0 here, let's go to S. Where is this? Come on, now. I can't find an S. There's one. All right. So for example, if we go to 0, it should be exact. Yep. So we'll do 0.001 and go from, okay, so that's good. So 2 looks fine. So this is kind of the trial and error process to see what works. So as you can see, that causes some weird issues there. We can also try having this to be 0.1. So this is what we get with 0.1. Okay. Oh, 0.1. Try 0.01. 0.009. 0.008. So it doesn't seem to be changing much with this. It looks like it's going through this and then starting over. It could be how I have the polyline exploded, where it starts. It could be this is where it starts for some reason, or how it's ordered, and then it goes through this. That's the only explanation I got. We can try this. Let's see how many points this gives us. It's all a matter of how many points it gives us. If it gives us too many, then we don't want to do that option. So as you can see, it's still less points. How many is this? 147,000. This is the whole text. So if we take the whole text here, do points on sell points 222. Control, like I said before, control points is better, still better than polyline points, because polyline points, it's how it's matching. Control points is just an average still. The average, mathematically, it's still better than that, but still less points. 222,000, and this is 147,000. So you can tweak this a little bit more and try different variations, of course, but I think that's pretty good. I don't know why it's, for some reason, I've had this problem too when I did this. These are the control points for it, but when you join them together, when you join them together, it looks like this. One thing we can do is do simplify curve and see how much we can simplify it by. Let's see. Oh, simplified curve. True, true, true. False, true, false, true. Okay. Yeah, it's still providing the same points. I think we'd have to do this. Simplify the curves. It should do some of them. And then we have join curve. Then we have this. Okay, interesting. I'm not too sure why it's still making these points on these lines. It's not recreating them. It's using the same points and then joining them. So one way to get around this is manually in Rhino. So what you would do is, this is another way. If you need these to be like full blown, like non-segmented. Why is that V so weird? What? That looks strange. Look at that. So another way you can do it is you can bake the two components here and then the call pattern, and then just join them in right now. But I'm not too sure why it's doing that. That's a little weird. Tolerance is optional tolerance, angle tolerance. We can just do this. Let's see what that does. We can look at the points too. So when we disconnect it. Okay, it seems to simplify those. So I seems to be simplified fine because it literally wasn't messed with. It was just straight letters. And then everything else seems pretty good though. I mean, okay, T. The only thing is, I'm like, why is it doing this? This isn't the biggest deal breaker. I'm just curious why it's doing that. But these are control points and not actual, what's it called? Oh. Oh, did I bake these? Like, what the hell's going on? Okay, so let's try this out. We can bake it. We can bake this. And then now we do ungroup because we don't want to do the whole thing. Is that cute like that? I highly doubt it. Oh no, it was. Well, that's just a weird looking cue. What was I gonna do? With S? No, it was T. Yeah, okay, when you click on it too. See, so the control points here are different than the actual points. So control points, just because if we explode this, we should get something different. Yeah, okay. Yep, because this is a control curve, and these are lines. Okay, yep, that makes sense. So, okay. So now I have that. And yeah, so now that we have our simplified curve, we are good to go now. We can use this D, S. As you see, it's a lot better than before. U, we have all these control curves versus the U that we had before, etc. O is the biggest example here. One thing you can do though is, since O is still pretty dense here, so cell points, you can see it's 90 points. You don't need all 90. Still 100, so you can see it's not much change. That's why when you do reduce, you want to see how much it's the actual reduction is doing. So this one isn't as reduced because O is pretty circular, like I said, so you have to really figure out what's good. The perfect settings for everything else may not be the best for O, so it's just optimizing what letters. So if you don't have a lot of O's, then it should be fine. If you have a lot of O's, then you probably want to optimize for that. So it's just dependent on, you want to make sure everything works before you start optimizing completely. So we know everything works here, so now we can actually start optimizing the whole thing and actually being like, okay, and then start playing around and tweaking around with these variables that we have. So the tolerances here, and then we can also play around with technically this a little bit. This usually stays pretty fixed. And then you can control this. Okay. But yeah, so that's pretty much it for this tutorial. So really I was just showing my thought process on how I simplified these curves. To go over really briefly, I'll just go over the script again. So I reference my curves, I explode them, find the lengths of all of them here, then do a filter smaller than. So what I do is every curve that is smaller than 0.39 will be in this layer, and then as you can see when I highlight it, it is. So that usually includes, and this is a workaround because we know that all these curves here are polyline segments, which are terrible. And then we have these curves right here that are the straight curves that we don't need to modify at all. So we're just leaving those for the end when we join them. Then we join the curves together, and then we re-explode these curves right here. So we join them, explode here, as you can see, draw draw the polyline for these. We could, no. So we did this to filter it, to get these lines, to then explode it, and then to redraw so it's exact, and then we reduce these down through a tolerance. So we can also use, technically, you could use simplify and go like 0.2, like this, something really high, like this, and then you'll get like crazy results here. Or 5, you could do. Oh, I need to turn up my tolerance, 0.05. So, but yeah, you can tweak around with this. 2. So we know that that works. Okay. So 0.02. So we know in between that, we don't want this much deviation. So we know that for sure. And then, so when I know that, I'll just raise it up by 3 and just do something in between. So 0.015. And then I'll be, okay, that's pretty good. So let's try 0.016. And then that's pretty good. So, and then 0.018. And that's my limit. So I'm like, that's what I want to keep it at. We want to make sure everything's pretty good here. So mess with these variables here. And yeah, alrighty. So, and then what was I at? So explode it, redraw the lines, reduce them, re-explode the reduced polylines. So we have those. So we have those points. There's another way you can do. You can also do shatter. So you can technically shatter at certain parameters. So you can technically take the points and you can technically take these points and then shatter it based off this if you find the parameters of each one of those points based off the line. But that's a lot more complicated. Maybe not. It just depends. I don't think so. I don't think it would be, but it's just dependent on I don't know exactly. I could be wrong, but that's another way you can do it. To if there's a different way, please let me know as well. Because at the end of the day, this is my discoveries. Doesn't mean I'm perfect or I'm amazing at this. This is what I've studied and really wanted to, or what I tried to get through in an iteration of the progress that I've made. If there's always someone that has maybe a different way of approaching it or a different outlook on it, and I always take that into consideration because I know that the only way to really learn is to listen to other people, even people that may not know as much or people that know a lot, because they always have different viewpoints on how to look at different things. That's just for anything that you do in life, but especially in computational design or even in design, you just need to listen. So then I re-exploded these, and then I took those, created a Kinky Curve, and then merged them together, simplified it, and then joined them back together to create the good text. Ta-da! So it's still not as good as this, or as this. And the reason why is because these are optimized based on per letter or per curve technically. But I had to do the entire thing, so it's optimized on the average based on the whole thing. So this may not be optimal compared to, let's say, this U, but it's averaged out in terms of optimization. In terms of time, I don't want to go through each letter and then optimize those settings. You don't want to do that. It just takes forever, and you'll never be done. So yeah, that's it for the tutorial. Hope you guys really enjoyed it. I haven't made one in a while, so this is pretty exciting for me. I like longer videos. I think I can be able to explain more and share my thoughts on certain things on this project and other stuff. So yeah, guys, thank you guys for watching. I hope you guys have a great day, and peace.